Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LGIT. Earlier lecture, we are already discussed about the L'Hopital rule and 0 by 0 form. Today's session, we are going to discuss about the infinite by infinite form and 0 into infinite form. Firstly, we have to discuss about the infinite by infinite form. Here, working rule of the evaluating the examples of the infinite by infinite form. If limit x tends to a, f of x equal to infinite, and limit x tends to a, g of x equal to infinite, then the L equal to limit x tends to a, f of x by g of x equal to limit x tends to a, 1 upon g of x upon 1 upon f of x. That is our 0 by 0 form. We have to apply L'Hopital rule is only 0 by 0 and infinite by infinite form. Remaining other indeterminate forms we cannot apply directly L'Hopital rule. Then firstly convert in form of 0 by 0 or infinite by infinite form. Then after we can solve that type of particular indeterminate form. Let's see the example which is based on infinite by infinite form. Limit x tends to pi by 2, log x minus pi by 2 by 10x. Firstly, we have to check which form is satisfied. Here, applying the x as a pi by 2. Then pi by 2 minus pi by 2, that is 0. Then log 0, that is infinite. The numerator portion, that is infinite. 10 pi by 2, which is also infinite. Then it is infinite by infinite form. Then we have to apply L'Hopital rule. Then it becomes limit x tends to pi by 2, derivative of log, that is 1 upon x, that is become 1 upon x minus pi by 2, derivative of 10, that is sec square x. Now simplified that term, then it becomes limit x tends to pi by 2, cos square x upon x minus pi by 2. Now applying the x as a pi by 2, then it is 0 by 0 form. If it is 0 by 0 or infinite by infinite form, then we have to apply L'Hopital rule. Then with the help of L'Hopital rule, derivative of numerator portion and derivative of denominator portion individually. We cannot go for quotient rule, correct? Then it becomes 2 cos x into minus sin x divided by 1. Now applying the limit x as a pi by 2, then it becomes 0, which is finite. Now let's see the one more example. Prove that limit x tends to infinite, 1 square plus 2 square plus 3 square plus and so on x square upon x cube equal to 1 by 3. Here firstly LHS portion, that is our 1 square plus 2 square plus 3 square and so on. Here given numerator portion, that is in form of exactly 1 square plus 2 square plus 3 square and so on. That is our standard. We have the standard formula, summation n square equal to 1 by 6 n into n plus 1 into 2n plus 1. Then it becomes limit n x tends to infinite, x plus 1, 2x plus 1 divided by 6 into x cube. Now whether we have to check which form is satisfied, obviously infinite by infinite form. Then each and every term has a x common. Here we have to apply numerator portion as an expanding form. Otherwise, common x in each and every term, and which is cancel out. Then our term become 1 plus 1 upon x into 2 plus 1 upon x divided by 6. Now applying x as a infinite, then it becomes 1 plus 0, 2 plus 0 divided by 6. Then it's become 1 by 3. That is our RHS view like. Now let's see the one more example. Prove that limit x tends to infinite, x raised to m upon e raised to x equal to 0. Here m equal to any constant value, or we can say that where m greater than 0. Let's see. Here firstly LHS portion, that is limit x tends to infinite, x raised to m upon e raised to x, that is our infinite by infinite form. If it is infinite by infinite form, then we have to apply L'Hopital rule. Then m x raised to m minus 1 upon e raised to x. Again we have to check, that is infinite by infinite form. Then again apply L'Hopital rule. Then similarly m into m minus 1 x raised to m minus 2 upon e raised to x. Again that is infinite by infinite form up to m minus 2 times. Then above expression we can write in form of limit extends to infinite m, m minus 1, m minus 2, m minus 3 and so on into 3 into 2 into 1 divided by e raised to x. Now in general form numerator portion we can write m factorial upon e raised to x. Now applying the x as an infinite, then denominator portion becomes infinite but numerator portion has a finite value, then anything upon infinite that becomes 0, that is our RHS portion. Let's see the one more example. Prove that limit extends to 0 log sin 2x base sin x equal to 1. This type of particular example is not a directly indeterminate form. Then we have to convert in form of indeterminate form. Here LHS equal to limit extends to 0 log sin 2x base sin x. Then with the help of properties of logarithm, which is change of base, then it becomes limit extends to 0 log sin 2x by log sin x. That is our infinite by infinite form. Then applying the L'Hopital rule, then limit extends to 0 1 upon sin 2x into 2 cos 2x divided by 1 upon sin x into cos x. Now simplified that term, the limit extends to 0 2 cos 2x upon cot x, that is our infinite by infinite form. Now convert that form, means cot x equal to 1 upon tan x, and simplified that term, then it becomes 2 tan x upon tan 2x, that is our 0 by 0 form. You all are aware about the derivative of tan x, that is sec square x. Then applying the derivative of numerator portion and denominator portion individually, then it becomes limit extends to 0 2 sec square x upon 2 sec square 2x. Now you all are aware about the value of sec x, that is value of sec x where x as a 0 means sec 0, that is 1, means here denominator portion does not 0 and numerator portion that is also finite. Then applying the limit and give the simplification, then we get 1, that is our RHS portion. Let's see the one more example. Limit extends to a log of x minus a upon log of a raised to x minus a raised to a. Here whatever the limit which is given, that is our L, that L equal to our limit extends to a log x minus a upon log a raised to x minus a raised to a. Firstly we have to check the which form is satisfied. Here infinite by infinite form is satisfied. Then applying the L'Hopital rule, then limit extends to a 1 upon x minus a upon 1 upon a raised to x minus a raised to a into a raised to x into log a. Now simplified that term, then it becomes 0 by 0 form, and applying the limit in a product form to individual, then limit extends to a 1 upon a raised to a into log a into limit extends to a raised to x in minus a raised to a upon x minus a. Then it becomes limit extends to a 1 upon a raised to x log a, and second term which is our 0 by 0 form. Then applying the L'Hopital rule in second term and applying the limit in first term, then first term becomes 1 upon a log a, and applying the limit in second term, then it becomes limit extends to a raised to x into log x. Now apply the limit x tends to a in second term, then it becomes a raised to a log a upon a raised to a log a, which is cancel out, and it becomes 1. Now let's see the third form, which is 0 into infinite form. Firstly, working rule to the evaluating the limit in form of 0 into infinite form. To solving the such kind of problems, limit extends to a f of x into g of x, where limit extends to a f of x equal to 0 and limit extends to a g of x equal to infinite. Or we can say that limit extends to a g of x equal to 0 and limit extends to a f of x equal to infinite. We can write that type of problems. Then limit extends to a f of x upon 1 upon g of x, or we can write limit extends to a g of x upon 1 upon f of x. Here 0 into infinity form or other than the 0 by 0 or infinity by infinity form, each and every example of that particular forms convert into the 0 by 0 and infinity by infinity form. That means we have to apply L'Hopital rule only 0 by 0 and infinity by infinity form. Remaining other forms converting to the 0 by 0 and infinity by infinity, then and then we have to apply L'Hopital rule. Let's see the one example. Limit x tends to 0, x into log x. Here whether check the which form of satisfy. Then x as a 0, then 0 log 0, that is infinite, means 0 into infinite form of, then converting to that form into the infinity by infinity form or a 0 by 0 form. Then here x that is written as a 1 upon x, then our limit becomes limit x tends to 0 log x upon 1 upon x. Then applying the L'Hopital rule, the derivative of log x, that is 1 upon x, derivative of 1 upon x, that is minus 1 upon x square. Now simplified that term, then it becomes minus x. Then applying the x as a 0, then it becomes 0, which is finite value. Let's see the one more example. Evaluate limit x tends to 0 square root of a plus x upon a minus x into tan inverse square root of a square minus x square. Firstly, which form of indeterminate form is satisfied? Here 0 into infinite form. Then converting to 0 into infinite form to the infinity by infinity or 0 by 0 form. Then in first term we have the square root of a plus x upon a minus x. Then applying the conjugate a plus x, means multiply and divide with a plus x in first term and simplified that term. Then a plus x into a plus x whole square or square root, that is cancel out, then it becomes a plus x. In denominator portion a minus x, a plus x, then we can write a square minus x square into tan inverse square root of a square minus x square. Then now here we have the two terms, limit x tends to a plus x into tan inverse square root of a square minus x square upon square root of a square minus x square. Then applying the limit to individual term, then first term becomes 2a into second term, which is limit x tends to a tan inverse square root of x square minus a square upon square root of a square minus x square. Now in second term, that is our, directly we can say that there is value of tan inverse square root of a square minus x square upon square root of a square minus x square, that is 1. But for the simplification or for the better understanding, with the help of substitution method, assume square root of a square minus x square, that is y. Now applying the limit x as a, then y becomes 0. Then limit y tends to 0, tan inverse y by y, obviously according to the standard limit, that is 1. Then 1 into 2a, that is 2a, which is finite. Now let's see the one more example. Limit x tends to 0 log of 1 plus x upon 1 minus x into cot x, that is in form of 0 into infinite form. Then converting to the 0 by 0 or infinity by infinity form for the simplification, here into cot x, then we can write cot x equal to 1 upon tan x. Then our term becomes log of 1 plus x upon 1 minus x divided by tan x. Now whether check this form of is 0 by 0 or infinity by infinity, then obviously it is 0 by 0 form. Then according to the L'Hopital rule, derivative of log x, that is 1 upon x, then it's become 1 minus x upon 1 plus x. Now remaining term again apply quotient rule, means d by dx of u by v, means v as it is derivative of u minus u as it is derivative of v divided by v square, and derivative of tan, that is sec square x, and simplified that whole term, then we get 2 by 1 minus x square into cos square x. Here denominator portion, that is finite value. Then applying the limit x as a 0, obviously value of cos 0, that is 1, and divided by 1 minus 0, means 2 into 1 divided by 1 minus 0, that becomes 2, which is finite. Let's see the one more example. Limit x tends to 1 x square minus 1 into 10 pi x by 2. Here given limit which is in form of 0 into infinite form, then converting to the 0 by 0 or infinity by infinity form. Then here 10 pi x by 2 means 10, that is 1 upon cot, then it's become x square minus 1 upon cot pi x by 2. Now that is our 0 by 0 form. Then applying the L'Hopital rule, then it becomes 2x upon minus cos x square pi x by 2 into pi by 2. Here cancel out, and applying the limit x as a 1, then denominator portion, that is finite value, and simplified that term, then it becomes minus 4 by pi. Now let's see that these all are the practice example, do yourself, and I hope you guys, you all are learned something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this topic, then feel free contact me. Thank you so much for watching me.